Hi everyone. In my today's session, I'm going to explain about what is the difference between a task and a thread in C Sharp, and then what is the difference between a multi-threaded programming and asynchronous programming. Okay, so before the introduction of TPL, the task parallel library in C Sharp, we had only multi-threading, and in most of the programming languages, we had multi-threading itself. So let's start with it. So what is this task and what is this thread? So what is task? A task is a future or a promise. Okay, a task is basically something you want it to get done. Okay, so that's why they say a task is a future or it's a promise basically. Okay, and someone has to fulfill that promise. So that's what a task is, and a thread is a way of fulfilling that promise basically. Okay, so think of task as a promise, and a thread is a way of fulfilling that promise, or thread is a person who basically fulfill that promise. You can use tasks to specify what you want to do, then attach that task with a thread. In .NET terms, a task represents an asynchronous operation. Okay, threads are used to complete that operation by breaking the work up into chunks and assigning to separate threads. Okay, tasks are tuned for leveraging multi-core processors. If you go to your task manager and open resource monitor, and most of our computers basically we are making use of the Intel core processor, multi-core processors basically. So I'm making use of Intel multi-core i7 processor, and I can see there are 7 CPUs basically on my single central processing unit. Okay, there are 7 cores and each core represents a CPU. So the tasks in C Sharp are basically tuned for leveraging these multi-core processors. Okay, so what is the difference between task and threads? Okay, so task, if system has multiple tasks, then it make use of the CLR thread pool internally. Okay, and so do not have the overhead associated with creating a dedicated thread using a thread basically. Okay, also reduce the context switching time among multiple threads. Okay, so advantage of making use of task is that your task basically make use of a CLR maintained thread pool. Okay, and in that thread pool your operating system has automatically allocated or created some threads. Okay, which can be used by your programs basically. Okay, so it basically avoids the overhead of creating a dedicated thread. Okay, and also it reduces the context switching time among multiple threads. Okay, in order to switch from one thread to another. Okay, so that is the use of, that is one difference of task. Okay, and whereas when it comes to thread, directly making use of threads basically limit your system's vertical scaling. Okay, so in case of thread, what happens, for each and every operation, okay, for each and every request, if you keep on creating the thread, somewhere you will meet that threshold, or somewhere you will cross that threshold of allowed number of threads in your system. Okay, so that way your program will become limited by vertical scaling. The task can return a result. So in a .NET, these tasks basically can return a result, whereas in traditional multi-threading, there is no direct mechanism to return the result from a thread. Okay, you perform some parallel operation and you update that operation's result in some shared space basically. Task supports cancellation through the use of cancellation tokens, which is a very nice concept. So basically you have ability to cancel a task, but that is not possible in case of threads. You can't cancel the thread. Okay, a task can have multiple processes happening at the same time. Okay, yes, if you have a task which is running some code, then there are multiple processes are happening at the same time. For example, you have created a task basically establishes a connection with the database server. Okay, gets the data, and then whatever data it got, it processes, and after processing it will put that data into a report or a file. So multiple things basically happen in a task, whereas threads can only have one task running at a time. Okay, see, always remember, okay, threads are meant to achieve multiple, or parallelism basically. Threads are meant to achieve parallel execution of your operation. So each thread will perform one operation. So if you create n number of threads, okay, each and every thread performs that only one operation in sequential manner. Okay, it is not doing multiple things at the same time. It only executes that particular operation in sequence. Only thing is it runs on a separate thread. Okay, so let's move on. So while using thread, if we get the exception in the long running method, okay, it is not possible to catch the exception in the parent function. Okay, so in case of threading, okay, there is a catch. If exception happens in your thread, so that thread cannot be basically passed to your parent thread, which basically triggered your thread. But in case of tasks, it is possible that if a child task throws an exception, that exception can be handled in your parent task try catch block basically. Okay, so that's what this statement says about. You can easily build chains of tasks. You can specify when a task should start after the previous task, and you can specify if there should be a synchronization context switch. Yes, you can create a n number of tasks and you can chain them so that after T1, T2 should execute. If T2 executes successfully, then go to T3. If something fault, if any of the task results in a fault, then what should happen? So all these things you can achieve with tasks, but same thing is not possible with threads, guys. You can't chain the threads. Okay, they run on their own. The only thing they can do is they basically signal your main thread, okay, or the parent thread which have triggered them in order to wait for them to finish. That's it. A task is by default a background task. You cannot have a foreground task. Okay, a task itself represents a background work. Okay, so you can't create anything like foreground task. But in case of threads, there are two categories: background threads and the foreground threads. Okay, a background thread most of the time works as a daemon, and sometimes it has a lower priority compared to your foreground thread. The default task scheduler will use thread pooling. So some tasks may not start until other pending tasks have completed. Okay, so tasks basically make use of the task basically make use of the default task scheduler. Okay, so until unless there are no threads available to your task scheduler, the task scheduler in turn checks your system or CLR thread pool. If there are no threads, then it will not immediately start executing a new task. So it will wait until you get a new thread and also other tasks are completed. But if you use thread directly, every use will start a new thread. Okay, in case of tasks, basically you are reusing a thread from a thread pool. But in case of threads, the moment you start a new thread, it basically ends up in creating a new thread, which is very costly affair. Okay, creating a thread is very costly affair compared to creating a task. Okay, asynchronous implementation is easy in task. So do remember, this is a very important point. You can perform asynchronous programming in C sharp using tasks only. Okay, so this async await keywords can only be used with tasks, but the same thing you can't do with threads in C sharp. Okay, so async await feature cannot be used with threads. Okay, so these are the main differences. So what is the conclusion? Task is almost always the best option. It provides much more powerful API and avoids wasting operating system threads. Task is an abstraction, so it is a lot easier to use. Most important being, okay, the most important thing being the support for asynchronous programming with the syntactic sugars in terms of async and await keywords. Okay, guys, so we should always make use of task itself in order to achieve asynchronous programming as well as multi-threaded programming. Okay, so with this introduction to task and threads, now it makes sense to explain the difference between multi-threading and asynchronous programming. So what is multi-threaded programming? Each parallel program consists of activities, each of which execute sequentially, and different activities run in parallel. Okay, so in multi-threading, the sequential activity is a thread. Okay, so you have a parallel program which consists of n number of activities, and each of those activities execute sequentially, but they basically uh, execute parallelly in nature. Okay, they are not dependent on each other. So in multi-threading, the sequential activity is a thread. So take an example of a garments factory. I think I have put a picture over here. So here each woman in this factory represents a thread which sequentially stitch a shirt or a pant basically. Okay. So if she's stitching a shirt, the other person will be stitching a pant. So this pant and shirt don't have any dependency between each other. They can execute independently and parallelly. So this particular person over here or any employee over here basically represents an thread. Okay, that's called multi-threaded programming. So our garment is basically a multi-threaded program, and that is basically invoking n number of employees called threads in order to perform the independent operation. That is called multi-threading. So what is asynchronous programming then? Okay, so an asynchronous program dispatches tasks to devices that can take care of themselves, leaving the program free do something else until it receives a signal that the results are finished by that device basically. Okay, so take an example of this picture. So this guy is asynchronously doing his laundry while speaking in phone with his wife. Okay. So once the laundry is done by washing machine, it will signal by giving a beep. Then he will continue with that machine. So he will take out the clothes and he will dry out. Okay. So this is called asynchronous programming. Okay, guys. So there's a difference between multi-threaded programming and asynchronous programming. They are not same. Do remember this point. So multi-threaded and asynchronous programming are two different things. And from the above examples, we can very easily say that multi-threading is a programming technique for executing operations running on multiple threads, or also called as workers, where we use different threads to block them until the job is done. This statement is very important. Each and every thread is blocked to that job until that job is done. Okay. So this is the way how your thread works. Once you assign a work for a thread, right, the thread is stick to that operation, and until and unless that operation is not done, either it's a success or failure, it will be stick to that. But in case of asynchronous programming is the concurrent execution of multiple tasks. Here the assigned thread is returned back to a thread pool once the await keyword is reached in the method. Okay, so let me explain here. So the moment this particular guy puts clothes into the washing machine and starts it, okay, so he's basically treat him as a thread. So he is basically detached from that operation itself. Okay, he will forget about that operation. Okay, he has started the machine, and this guy will pick some other task. So he received a call. He basically called his wife and he started speaking with her. Okay, he forget about this laundry task now. So once this task is successfully completed, right, this machine will signal him, and again what he do, he basically once again listen back to that machine and he will do that operation. Okay, so this is what happens in asynchronous programming. A task is freed the moment it finds a blocking operation. So task is returned to your task scheduler, or you can say the thread associated with the task will be freed and it will be returned to the thread pool. And once that operation is successfully completed, that means signaling the results. Once the results are ready and you receive that signal, one more thread will take over and performs the operation or continues the operation. So this is the main difference between multi-threading and asynchronous programming, guys. Okay, so let's take an demo now. I will demonstrate with a program how it works. So a very simple example I'm taking, which comes in our day by day life, which is preparing the breakfast. Okay. So suppose you are preparing the breakfast. Okay. So let's take the example of asynchronous programming now. Okay. In asynchronous programming, basically how we achieve this. Okay. So I have some asynchronous methods written over here. First one is which prepares the juice. Second one is it's a operation which toast your breads. Okay, and then the third operation is it boils the eggs. Okay, these are three asynchronous operations basically. Okay, so now let's have a look at the main program. Okay, so what I'm doing, I'm starting the juicer for orange juice. Okay, what I'm doing, I'm starting the prepare juice task. Okay, so what I did, I triggered the prepare juice task. Okay, that's it. Now what I'm printing, meanwhile, take the glass from the shelf. So while my juicer is preparing my juice with oranges, what I do in the meantime, I'm going to take the glass from my shelf. Can you see? Okay, so I started the button on my juicer. Okay, and I forget about it. Okay, my juicer will let me know once it is done. Okay, so I don't worry about it now. Now I will switch to another task, which is taking glass from the shelf in order to pour that juice into that glass. Next, once I took the glasses, okay, now I'm starting the toaster to toast the bread. Okay, I started the toaster now here. Okay, now I pressed the button on toaster. Now it has started to toast the breads. I forget about it now, okay, because once done the toaster will give me a signal. Okay, so meanwhile I'm taking the plate from the kitchen drawer. Okay, and then also what I'm doing, I'm taking the butter bottle and spoons ready. Okay, so once the breads are toasted, what I'm going to do, I'm going to apply butter on the breads with the help of spoon. Okay, so I started the toaster task again. After that, what I did, meanwhile, I took the plate as well as butter bottle and spoon. Then what I did, after taking the butter bottle and spoon, what I did, I started the boiler in order to boil my eggs. I pressed the button on the boiler. Okay, now boil eggs task started. Okay, so now once it is started, again I don't worry about that machine, the boiler machine. Okay, so what I'm going to do, the next thing, I'm going to wait for the toaster now. Okay, what I'm doing, I'm basically awaiting on the toaster task. Okay, so once the toasting task is completed, this await basically signals me that the toasting task is done, the breads have been toasted now. Okay, so the breads are ready. So the moment I put a awaiter here, okay, and once the execution comes over here, right, I'm damn sure that the breads are toasted. So what I'm doing, breads are toasted, apply butter on breads and put into plate. Can you see how things are happening asynchronously here? Okay, then once breads are toasted, I applied butter on the breads and put into plates. What I'm doing now, I will check for whether the eggs are boiled or not. Again, the boiler machine will give me a signal. Okay, or it will give a beep. That means await. Once again, this is a signaling. Yes, eggs are boiled. Put eggs into plate and start eating the breakfast. Okay, so I have started eating the breakfast, and the meanwhile the juicer will also give a beep saying that yes, the orange juice is ready. So once I receive that signal, juicer has completed, pour the juice into glass and start drinking. So can you see, if I would have gone with a sequential way, right, it would have taken a lot of time. First I would have prepared the juice, I waited for 10 minutes, then toasting the breads, I waited for another 10 minutes. Okay, again, while doing these things, again taking the glass from the okay, taking the plate from the kitchen drawer and taking the butter bottle, again these would have taken one more extra minute. Okay, and boiling the eggs would have taken 15 minutes. Okay, so if you sum up this, no, it would have taken more than half an hour to do the same breakfast. But with asynchronous programming, everything happened parallelly. Okay, I started the juicer machine. Okay, and meanwhile I took the glass from the shelf. Again I started the toaster. Again I started toasting the breads. Okay, I pressed the power button, and meanwhile I took the plate from the drawer, I took the bottle, spoons, I kept everything ready. And meanwhile also I started boiling the eggs. Okay, the eggs are boiling now. I forget about that task, and what I did, I waited for the signal. I awaited for the signal. Okay, I got the signal. Meanwhile, my eggs were boiling. I got a signal that breads are toasted. Okay, I put the breads, I applied the butter on the breads and put it into the plate. And while doing this, applying butter and putting the breads onto the plate, I got a signal from the boiler, the egg boiler, that the eggs have been boiled. So eggs are boiled. I took the eggs basically and kept into my breakfast plate. Okay, while doing this, again I got one more signal where the juicer has successfully completed. So I pour the juice into glass and started drinking. So this is called asynchronous programming, guys. Okay, so with this setup, I think I was able to prepare my breakfast within 15 minutes. Okay, so this is called asynchronous programming. And this async and await basically are the keywords which are used to achieve this asynchronous programming in C sharp. Okay, so this async and await are basically what happens, when compiler compiles this program, right, internally it converts this program into a state machine. Okay, so wherever it finds a await, basically async and await, right, all these awaits are basically converted into a state machine. Okay, so with the help of ILDASM disassembly tool, we can very easily see that this particular main function basically converted into a state machine class. Okay, and used by the runtime basically. Okay, guys. So let me run the program. Now, in order to demonstrate multi-threading, what I have done is I created a class called multi-threading. So same task, preparing a juice, toast the bread, boil the eggs. So while preparing the breakfast, these three are independent tasks because juice is not dependent on bread is not dependent on eggs. Okay. So these three activities can be run parallelly. So what I have done is basically I have written a very simple method. Okay. So just see the difference. Okay, in case of tasks, what I'm doing, public static async task prepare juice, and I'm simply simulating that work by calling await task dot delay 1000. So just make this method to wait for 1 second basically. Okay, in the same way for the breads 1 second and for the eggs also 1 second. Okay, now in case of multi-threading, I'm using thread.sleep. See, I'm not using async and await anywhere here. Okay, this is multi-threading example now. Okay, so thread.sleep for 1000 milliseconds. Okay, so before calling thread.sleep, what is the thread ID? After calling thread.sleep, what is the thread ID? Okay, let's check this in case of multi-threading and task based parallelism. Okay, in case of threads and in case of tasks basically. So here also we will check what will happen before calling task.delay and after task.delay. Okay, let's see the magic over here guys. Okay, so I will run this program. Okay, the program runs successfully. Okay, so in case of preparing breakfast in asynchronous way with tasks, what happened? Okay, the asynchronous operations or tasks were called by a thread with thread ID 1. That is our main thread. So all this prepare juice, toast breads, boil egg, all these three tasks were basically triggered by my main thread with thread ID 1. Okay. But see, when the prepare juice, toast breads and boil eggs async methods completed and continued, can you observe the thread IDs? They are separate 6, 6, and 7. Can you see this difference over here, guys? Okay. So, in case of asynchronous programming, whenever a thread initiates a blocking operation, okay, the moment it identifies a blocking operation, right? Okay. So, what happened in case of tasks? Okay, the moment it triggers a blocking operation, it will free that thread, the attached thread to thread pool. Okay, it will simply it will simply free that thread to the thread pool so that it can be used by some other tasks which are in need. Okay, so once the operation, the blocking operation, it may be a IO operation, it may be a REST API call, whatever it may be, a DB operation, once it's successfully completed, it will signal. Okay, it basically signals your program. So how that signaling happens? The signaling happens using this await keyword. So when task.delay spends 1000 milliseconds, after 1 second, it will signal your program that this blocking operation is over. So in that time, what happens, whatever thread was freed here, okay, that thread will not continue the operation, the further operation. No, okay, the thread which was used to trigger this task was freed up. Okay, it was taken by some other thread basically. Okay, or task, you can say it has been taken by some other program or some other task. Okay, now after this blocking operation is successfully completed with this signal, so whatever available thread is available in the thread pool, that will be attached to this task and task will be continue. The remaining operations of the task will continue on that thread. Okay, that's the beauty of asynchronous programming. But what happened in case of threading? Let's see. Prepare juice on thread with ID 11. Okay, now see, when this prepare juice operation was completed, it completed on the thread 11 only. Can you see? You basically blocked a thread right from the starting of a blocking operation till the successful or failed completion of that operation. The thread was attached. Okay, this is basically limiting your application to scale vertically. Okay, you are not allowing other programs or other tasks in your program to utilize the thread. You are basically assigning for each and every asynchronous, sorry, for each and every parallel operation, you are assigning a thread. Okay, this way, if there are 1024 parallel operations, and if you assign all 1024 threads, then basically you are ending up in losing all the threads available to your CLR or your operating system. Okay, so you would see the same here. Toast bread started on 12, toast bread ended on 12 only. Same for the boiling eggs, started on 13, thread ID 13, and ended on thread ID 13 only. Even if they executed in arbitrary manner, but they blocked the thread. But here, no. Okay, here the thread on which the blocking operation was started, okay, the moment the blocking operation started, the thread was freed up. When that blocking operation was successfully completed, another thread took over and completed that operations remaining statements. Okay, so your async and await keywords basically help you to perform asynchronous programming. Okay, they basically allow you to run your program in a non-blocking way. Got it? That is the crux of asynchronous programming in C sharp or equivalent in other programming languages. Okay, so I hope you people understood the difference between this. Okay, as I have already explained. Okay, so that's the main difference between the multi-threaded and asynchronous programming, guys. Okay, so I hope you people understood this concept, and I hope it will be useful for your day by day design. So the preferred approach nowadays is asynchronous programming, because asynchronous programming internally makes use of threads only. Okay, see, do remember, a task is a high level abstraction provided by your .NET programming language. Okay, it doesn't create any thread. In the same way, the thread class used by your .NET programming language doesn't create a thread by its own. Threads are created by your operating system, and operating system is the only one program which provides you the threads. Okay, do remember this. Okay, so there are a heavy, I would say, creating a thread is very time consuming operation and resource intensive operation, because a thread sometimes requires its own memory, okay, processing resources, okay, as well as the process which creates the thread, its address space, okay, and its data space. Okay, so whenever you create a new thread, it comes its own overhead of creating the threads. Okay, so in order to avoid creating thread for each and every operation, what you can do is you can basically make use of asynchronous programming, where asynchronous programming in a very intelligent way, whenever it identifies a blocking operation, it will automatically free the thread, and once that blocking operation is successfully completed, it will check for available thread from the thread pool. Whatever thread is free available, it will take and resume that operation with that thread. This way you are basically, okay, uh, allowing your system to utilize the maximum number of available threads in your thread pool. Okay, so that is the main advantage of asynchronous programming. Okay, so thank you for listening and have a nice day, guys.